somehow got reverted to V4, which is going to be a problem. So, all right, let's
Okay. How did that feel? Okay. Okay, 1:30 and all's well. How many people in the room have never seen the note well before? Okay, there's one. Okay, so note well.
So we have a couple of announcements as we start. Let me start with, I'm Lee Howard, that's Fred Baker, that's Ron Bonica. We're your co-chairs for V6OPS. If you're not here for V6OPS, then you need to figure out where you want it to be. A couple of material items. Michael Abramson is our Jabber scribe. He's sitting next to the front mic. He asks that as you approach the mic, please approach the front mic so that he can see your name tag, and please have it visible to him so that he can spell your name correctly. Barbara Stark is taking notes in Etherpad. Thank you both very much. I love this working group because I didn't even have to ask for help. People came up to me before the meeting started and offered. That's fantastic. One of the things some of you may have noticed is the V4 SSIDs for IETF have been disabled in this room. You might see some leakage from those SSIDs from the adjacent rooms. Please don't use them because then then those will get overloaded and performance will be poor. I have actually just accidentally tested this and determined that, in fact, performance is poor for me on the IETF main SSID because I'm pulling it from the access points over there. I didn't mean to be on that one. So, furthermore, therefore, please, if you're going to be online, please join one of the IPv6 enabled SSID, the V6 only or the NAT64 SSIDs, and please report tickets to, was it tickets.ietf? Tickets.meeting.ietf.org. We would love to see problem reports so that we can figure out what to do about them. So that is just for this room and just for the duration of this meeting. Everything will be re-enabled after we're finished here, but it seemed like this would be a good place to do this experiment. Here we have our agenda. Any further announcements? All right. So we have somebody from Cisco is going to, oh, here you are, good. Do you have the clicker? Speakers, please stand inside the pink box that's here in front of this microphone because you're on camera and remote participants can't see you if you're on camera, if you're outside the box.
Thank you. So hang on, I'll have your slide. So you're on.
Hi, good afternoon, everyone. My name is Khalid Javed. I'm part of Cisco IT and worked with the team that helped deploy IPv6 only in one of our buildings in the San Jose campus. I've been with Cisco IT for a time now, and I just want to call out at the very beginning, this is my first IETF. Please be gentle. 2, I am from IT. I am not from product management or product development, and I sit with you guys in those chairs, not this side of the fence, right? So I'll take those questions, but I'll just pass them aside, right? So on my agenda, I've got an overview, a dual stack recap, because we started back in 2009-ish. What we did with Building 23 in the San Jose campus and our data center plans. So we are just like any other large enterprise that you would expect to find. I'm not going to count out each of these. You can all see them. But roughly, we're looking at about 5 million IP address assignments, right? They may not be live endpoints. They're allocations, assignments. And that's pulled from our address management database. And that's the kind of scale we're looking at when we're talking about going to IPv6 only or dual stacking our infrastructure. We have 11 IPOPs across the world, which are advertising and ARIN provider aggregatable /32. We have one /32 prefix from ARIN that is being split up and advertised across the world, right? We run EIGRP internally, end-to-end, and all our management for current infrastructure is over V4. We're using the Cisco Network Registrar, or CNR, for our DHCP-V6 assignments and for V4. And we have put Slack in special locations in the network as an exception. So we'll talk about that. So most of the network that we have was dual stack back when we did World V6 Day and World V6 launch. So we were dual stack before World V6 Day. We started core outwards. And it was dual stack extended everywhere, but there were areas where we could not do it because of various gaps, let's say, in the products or in the way we were doing things. There are some pilot deployments that we have not taken forward, and those include the extranet and the Cisco Virtual Office, which is basically the home office that employees are using to access the Cisco corporate network. The pilot CVO, or Cisco Virtual Office, that's done, it's really carrying IPv6 tunnel inside the IPsec VPN. It's not native IPv6 on the external. A quick overview of our timeline. We did World Day, we did World Launch. We've done Building 23, learning lessons from them. We are looking to go out and develop this design for the data center side as well. It's in POC stages right now for a V6 only data center pod. And we're focusing on getting the training and development off to the teams, specifically the application developers. Getting them awareness around the need to develop IP-agnostic applications, especially as we move towards a microservices architecture. And we're hoping to mandate all new applications be IPv6 only. I'm not going to put a date there, but the unofficial personal view is that it might happen sometime in 2019. Right? But these things are controlled by people who have different agendas. Okay, so coming over to Building 23 in San Jose. So it was a single campus building that was targeted for both wired and wireless. Mobile devices as well. We had a NAT 6.4 and DNS 6.4 setup to look after the translation. Management and data. So the bit that was doing IPv6 only was also being managed over IPv6. And it included all the unified comms applications as well. It did not include building management systems for health and safety. Right? They were still on the V4 production, obviously, because they themselves, for example, badge readers or various security cameras, etc., they're still not fully IPv6 only capable. What you see in front of you is the physical topology. It's a standard design for Cisco IT. We had a NAT 6.4 setup that you see on the right-hand side, and we had a DNS 6.4 setup based on Bind 9. The 3850s are a typical switch stack along with the 4500s and the 3800 APs for wireless access. So the IPv6 only bit started from the 6500 virtual switching system that you see, 2 green boxes. From there, northward, it was IPv6 only, and of course, everything below that was IPv6 as well. Now, I want to call out here that the cloud that you see on the top is the Alpha backbone. That is a semi-production network that we have. It's used to bring the business units in. So our core, and it hangs off the distribution layer for the San Jose building there, which is dual stacked. So I wouldn't say that that's an entirely production network. It is semi-production in that it is not bound by the constraints that you would have from a change request perspective that normal production networks would have. And that's the reason why I hooked it up there, because we didn't have to file change requests or anything in case we wanted to do something very quickly. Okay, moving on. The features we deployed are standard. Everybody expects these. I believe nothing new here. First hop routing, first hop security, and all the IPv6 security features that are available across our platforms for IPv6. We are doing DHCP-v6 stateful by default, and Slack is there only as a special case because of the attribution forensics issues that sit behind privacy addresses there, right? I already called out EIGRP for IPv6 and, of course, NAT64, DNS64. Some stats, they are from the 14th of October. We had a peak of 500 users. This was on the day that invited everybody to come on in and log on to the IPv6 enabled corporate SSID there. It took us 3 months to do the entire deployment. That means it's still running. It's not we ran it for 3 months and we stopped it. It took us 3 months to do the entire deployment, approximately 7 to 8 engineers, and the average traffic we see there was about 250 megabits per second. This is on the northbound links from the Catalyst 6500 pair that you saw there. Approximately 32,000 NAT64 translation entries in the boxes there. This is a chart for the NAT64 translation table entries. As you can see, we peaked at 32,000 approximately. The dips are obviously the weekends when there's nobody in there. I'll call out why we couldn't gather it under SNMP. We were using a script because it's not supported. There's a slide on that. Okay, IPv6 only DC is still in the POC stages. Single pod we're targeting based on our ACI fabric, which is application-centric infrastructure for those who don't know. We're just doing the data plane, NAT64, DNS64, of course. We're doing a combination of stateless and stateful NAT there. If there is budget, we intend to do a pod per quarter starting FY19, again, subject to approval. That's the high-level topology. Again, it's pretty straightforward with the NAT64 setup there. The DCC or the Nexus 7Ks that you see towards the right-hand side, the two blue boxes, from there on, it's all dual stack outside. Okay, I'll come over to the issues and challenges we faced while we were doing this, which is probably something that you guys are more interested in. And let me tell you, it's working. So there's nothing we couldn't work around, right? I'm just calling these out because these are some of the stumbling blocks that we had to find a way around. Any connect issues on the Mac only, resulting from some software problem with an upgrade and a code fix. This was resolved. There's apparently no MIB for extracting translation information from the NAT64 boxes. So we filed an enhancement defect there, but I don't know what can be done about that if there's no standard, right? We had an issue with our Cisco TV or Infinite Video, which was an acquisition. Again, it was a back-end upgrade that fixed the problem. We had issues with Jabber clients. Again, it was an upgrade to version 12 of the CUCM, the Cisco Unified Communications Manager, the Call Manager server, and it was resolved. So users sitting in building 23 could use Jabber. They could use Cisco TV. They could use applications via the NAT64 to connect to IPv4 only applications. And yeah, I mean, on the day we had a war room. There were initial issues, but everything settled after that. We had Spark that was also working, but only the application. The web-enabled side of Spark, the web-based bit was not working. WebEx has an IT infrastructure that is not under Cisco IT. It has a separate IT infrastructure, and it's going through its changes. So We had issues there because the load balancer was quite old and it would send surf whale, and the NAT64 would not be able to, synthesize a quad A. But again, it is a GSS upgrade thing that's going to resolve that. So that's the long-term fix. And this only happened when they failed over to a data center that was not IPv6 enabled. WebEx is otherwise IPv6 enabled. Finally, Ipv4 Literals. We had engineers sitting there who were using Ipv4 Literals to get to their labs, and there's no fix for that, right? So, I mean, we worked around by coding those Ipv4 Literals with dashes into the DNS servers so that we could just accommodate them for the time being. Right, so privacy extensions are quite an issue with us, especially with Slack. There's a significant Android user community across Cisco. We don't have that problem with the iPhones, right, with iOS, but with Android, we have this problem. And we are not essentially against this. All we want is that InfoSec have the ability to track these address rotations as they happen. Or that means so for that, we have to develop a tool to somehow figure that out, right? Or we do something called device profiling, and we say that if you've enabled privacy extensions, then I can't let you join the wireless network. So that is why I'm asking Google here, can you please give us the switch to switch this on or off so that we can decide at a corporate level whether devices which have enabled privacy extensions should be allowed onto the network or not. And then it's the user's choice. The RFC mandates it. It says it's a must. It's not a should. So, I mean, you're not really following the RFC by not providing that switch. Okay, gaps and issues on the data center side. I'm going to open up the entire slide here. So wide area application services, this is a Cisco device that does WAN optimization. It doesn't support IPv6 yet. I'm complaining to Cisco standing here today, right, by calling this out. We need that. So hopefully they've got it in the roadmap, but as priorities have always shifted things around, it keeps slipping. Kubernetes is actually resolved. This is slightly dated information. We do have IPv6 support there since March, but from an internal IT perspective, we're still looking and working on this there. Pixie Boot doesn't support IPv6, and storage. My storage architects tell me that if I was to go IPv6 only, their pools will be fragmented, and understandably. Right, and if they're fragmented, then you still have to go through some kind of a translation infrastructure to go between the pools, or I guess you'd have problems having VMs moving around or things to that effect, right? So storage pools are an issue when we look at the data center if you're IPv6 only. That's as long as there is IPv4 stuff that is trying to access them. So we'll get more on this as we further develop the design. All right, the larger issues. Oops, I skipped this one. Dual stack adoption has held us back from the latest innovations. Now, what I mean by that is because we were dual stack entirely across our access network in 2012 when we did world launch. And as the BUs developed products that did not do IPv6, we suffered there because we couldn't put those out into our network every time claiming that an X amount of traffic from our network is IPv6. And if whatever you're developing does not give us the ability to add value to that flow, then it's a bit of something that held us back. We did find workarounds for this, but this is something that is going to be an ongoing issue as long as the people that hold the budget and who decide the priorities about developing products do not make sure that IPv6 is part of that. Making the business case for dual stack was hard. For IPv6, it's hard and risky for IPv6 only. What I mean by that is, so we got everything into dual stack. Now, as people try to go into IPv6 only, application owners come up and ask, all right, so what if it breaks? So now there is a line where you have to convince them that you need to move to IPv6, and then there is a line that says, okay, what if it breaks for people who don't have IPv6 or have to go to translation infrastructure? So that's a message I hear from people I talk to. And this message is still not flowing downhill. I want to take everybody back to 2011 and 12. The service providers had a use case. They needed growth, and therefore we gathered the momentum, and we did IPv6 Day, and we did IPv6 launch. We had the content providers come in, and we said, okay, that's really no good until we get a lot of the service providers in, because, yeah, things will still be going through translation infrastructure. And we had a lot of momentum. So between 2 and 3 years, we had the graph go up like this, right? Now it's 5 years since then. And still, the application owners are not convinced that they are ready to go to IPv6 only. And I think that momentum comes down to the leaders who are sitting at the top, from folks like you who influence their thoughts. It doesn't go bottom up from people like me. And that's what I mean by the message is not flowing downhill yet. Because we've done our bit. On the infrastructure side, we've dual stacked, tried to minimize the risk. We've even taken a building onto IPv6 only. But going forward, we're ready, but the application owners are not convinced that they want to go there just yet. I'll give you a recent example. Kubernetes port came in sometime like March 2016 for IPv6. Now, we are doing a microservices migration for all our applications, and I was very keen on making sure that we have a playbook where we lead by example and have developers do IP-agnostic application development, saying that, yes, we can do this over IPv6 only. But if the overall architectural direction that the applications are moving to, things like those are late in doing IPv6 only, then I've lost the case. It then suddenly becomes a disincentive to go there, if it's not doing that. Furthermore, I know that we are doing some kind of an overlay NAT for V4 for the microservices piece now. That further, aggravates the problem of people not trying to go to IPv6 only. So that's my feeling on this, that's what's happening out there in the wider world. And there was a great team behind this, and I just wanted to stand and acknowledge those people who spend a lot of time doing this. Okay, if there's any questions, I'll take them now.
Hi, David Skenazy, Apple. Regarding your point of device tracking and a global switch for privacy addresses, as someone who makes user-friendly devices, don't expect me to put in a switch for IPv6 privacy addresses. That's not what the user wants. Also, privacy addresses are beneficial. Prevents some website from tracking them, whether the device is on your network or not. If you really want to track them, why aren't you tracking based on MAC address?
Okay, so your question is the user would want that. That's you deciding for the user. Let the user...
Yes, that is my job, to decide what is good enough for the user.
I think that it can be debated, but I think that when you sign up to a corporate network, you already sign a contract. You're already signing to agree with the policy. If your corporate policy says that, yes, no privacy extension, then it's the user's choice. You can come on or you can not come on.
So your corporate policy is that now if I'm on your network and going to some public website, I have less privacy because you didn't figure out how to track at layer 2?
Yes, exactly. That's the case, because we set out the policy. You could go to the policy and find 200 other lines which say, oh yeah, why are you doing this? Because I should have rights. So it's legal has to face a lot of legal obligations. They have to make sure that they're in compliance with a lot of things. That's what they tell me.
Okay, would you also like a switch for me to disable TLS while you're at it?
I don't make that policy. I'm just telling you that this is what's preventing Slack going out. So you can either take it like that, all right, we are going to leave it like that, we're not going to do it, and help not let IPv6 only proliferate, Or you can say, hey, user, here's a switch. Your choice.
Agreed.
Thank you.
Thank you, Marco Groningrad, Pensie. Thank you, great work, especially coming from a vendor. Eating your own dog food is always good. I spend a lot of time kind of selling this at a high level to all sorts of people who are not engineers. And I'm still a bit confused in the message here, because you're telling me that this is a message that needs to come, or decision needs to be made top down, but it's costly, it's high risk, and essentially you're already dual stack. So you should disable IPv4, which I don't sort of, are you suggesting that people who are already dual stacking should move on to IPv6 only? Or are you now pen testing something that's supposed to be a greenfield deployment? Because I kind of don't see the path from dual stack to V6 only. If you've got a working dual stack, then shouldn't happy eyeballs take most of the strain and make IPv4 disappear?
Okay, I had some difficulty hearing you, but I guess you're saying that if you're dual stack, why are we not going to IPv6 only? And happy eyeballs?
Yeah, once you've got dual stack, you've got IPv6. So I call the job done.
Yeah, but happy eyeballs is more of something that we found to mask a lot of connectivity issues. We feel that dual stack is not the way to go forward operationally. It should be IPv6 only, and happy eyeballs doesn't help at all in making sure that IPv6 connectivity is really working there.
I suspect, Lorenzo Colidi, I suspect that what Marco is actually saying is that it falls on you to claim a lower burden of operational cost to justify moving to V6.
Oh yeah, that's not the only thing that defines the equation. That people who are developing products, they've got other revenue targets to meet, I guess. Yeah. So operational costs, we are already saying that we do not want to maintain two protocols. We're already saying that the way we would like to go, ask me to do it again today, and I'll do IPv6 only, and I'll invest everything I possibly can into a translational infrastructure so that I can work out the kinks there. But we are dual stack.
I shouldn't have said you. I should have said people like you all across the industry. When the operational cost will basically start being substantial enough that people are going to start asking themselves, why do we need this V4 thing anyway? That is the point when your app developers are going to listen.
Yeah, absolutely. So let me tell you where I stand on that. And I'm talking about people like me. Hopefully other people have their opinions, maybe, I don't know. But from my perspective, operational costs are owned by a different budget owner, and application revenue is owned by a different budget owner. So you have to look at it from the top down. You see, the guy out there whose application is bringing in billions of dollars of revenue does not own the operational costs.
No, but his customers would like to use them. The customers that buy that application that are suffering the same operational costs that you are suffering will eventually request that as a feature. That's what I meant.
So absolutely. And that message again comes top down. It still doesn't flow bottom up.
Okay, so now on the privacy address front, you're correct that we don't implement 4941 correctly. I would ask your InfoSec people, do you want everyone on the internet to track your users in perpetuity? Because if you disable privacy addresses, that's what's going to happen.
I've had this debate with them myself. They say they need to meet legal obligations, full stop. You see, now when you put the legal wrapper around it, I can't say much more because I'm not going to go and sit down and change, I don't know, any legal law that requires people to track stuff. But I hear them when they say that, look, when you switch on your laptop or your PC into the office, you are agreeing to a code of conduct with respect to the use of the network. And that has so many other clauses that you wouldn't normally agree to.
Yeah, I'm just saying it's their job to protect your employees as well. And by disabling privacy addresses, they're putting a big target on their backs. But I'm not going to try to argue with these people.
But I say that if you do not want to implement it, I say to Google, if you don't want to do it, then go get the RFC revised. If the RFC says it's a must, you should do it.
Okay, we'll do that. Okay. Now, if we can get consensus on that, we will, and we'll start the process of trying that.
At the end of the day, maybe 2 years down the road, you can say, we don't need this anymore. Everybody agrees that we should have privacy extensions, and that's good. But if you do that today, it will help people who are not deploying Slack because of legal issues deploy Slack and allow IPv6 to come on.
But then forever we will have no privacy. So there's a trade-off. So another point I wanted to make is that the legal The consensus statement of the IETF on this topic has been published. Okay, it's written in RFC 7934, and it contains detailed text about address tracking and what is recommended in the IETF. I would recommend that you follow that advice, because that's the advice of the IETF. That's really all that we need to say about this topic.
So we should go back, and in addition to developing or spending all the money to do IPv6, we should also spend the money to develop special tools to track addresses, because you don't want to implement an RFC.
You have the tools. Your devices do this. They send syslog messages when new neighbor cache entries are created. That's written in the RFC. Implementations are there. I mean, so like I said, read the RFC, and we would be happy. So there's a flip side also, right? We're trying to look at this for the long haul. What we're trying to see is, what can we do with multiple IP addresses that you can't do with just one? And we're starting conversations about, like, how can you sign an IPv6 address to an app? The Firefox people are saying, how can we sign a different source IP address for every origin server to preserve privacy? There's all these things that we're going to require multiple addresses on hosts. And just saying there's only one IP address per host is not going to allow all these things. Now, I realize that there's a tension there, but I think we should think about the long term a little bit more. And I did have some conversations with people at Cisco, and I think there was general agreement around the table that it would be better to base this tracking not on an IP address, but on a solid attestation like the 802.1x cert, right? If you want to build this, come talk to us. And I think that's a way better solution for everyone.
And we have that. That's how we have turned on Slack for those people. But
Let's do it.
Right?
So then do our devices do what you want already?
No, I don't know. I haven't gone down in the details there. So
but then let's talk.
We have turned on 802.1x for Slack there. I'm not privy to the details whether we actually track once the device changes its address. I don't know about that, because I was not involved in that.
You may also consider, final point, you may also consider the IPv6 prefix per host draft, which gives you a much easier way of tracking this, since you only have to track one thing at a time. You can assign the host one prefix based on radius, and that will give you tracking from IP to MAC. And if the device randomizes its MAC, you're SOL, just like you are today.
Absolutely.
So it's no different.
I'll take that on board.
But we will do this, and you're going to have to be the owners of the device to disable MAC address randomization.
Yeah. I'll take that back, and we'll see how we can change the way we design our network to do that. Thank you.
Daniel,
A quick thing here. I'm capping the mic, so we need to move on to the next, but go ahead.
Okay. Quick question. I'll keep it brief. Do you have anything online, like a blog article or something that has a little bit more detail than just the slides, but that's not video, that somebody could read? I'd love to share this more widely on mailing lists and social media as it is, just as a use case, your experience.
Yeah.
Do you have anything that's easy to share?
There are more details on all the issues and challenges and the use cases, and they are going to be written in a blog article, and I'll be happy to share that, or you can find it on our Cisco's website.
Thanks.
Janine Cole, Google. First of all, thanks for presentation, very interesting. But as someone who operates a corporate network, I definitely would not like users to have privacy addresses disabled, because they would not enable them when they walked out of the door. They would not do it every time they come in the office on morning, disabling privacy address and then re-enable them after. So we actually, because we just do not have right tools in place, we should not sacrifice security and privacy concerns. So probably we should concentrate on getting the right tools, like telemetry for MAC to IPv6 address mapping and so on. I think it's better place to put effort.
Fair enough.
David Skenazy, so I am not a lawyer, and if someone is and knows this rules in the great city of San Jose, please come and correct me. But I highly doubt that the regulations stipulate exactly how you need to track users. They probably only tell you that you should track users. So the fact that you're doing it on IP address and not on MAC address, you can't hide behind the legal requirements here.
I don't know how you're doing it.
It's just a technical thing.
I don't know how you're doing it. This is an this is an InfoSec thing. It's dark circles. Even I'm not privy to that. What tools they have, what attrition mechanisms they have there. But the feedback I got from them was that if it's in the RFC, it needs to be there. If it's not there in the RFC, then they'll have to redevelop their tools.
Okay,
That's why I brought it here.
And that's a fair response. I mean, I've dealt with InfoSec teams before. And while you're not privy to their decisions, I would suggest you go back to them and tell them that they're not privy to the host OS decisions. So we're not going to enable this, and just tell them that.
Okay?
Okay.
Thank you very much.
colleague.
So I'm standing before you not as a working group co-chair, but as somebody who did some fun activities over the weekend with a bunch of people here. Of course, you know that the IETF, we've been hosting a hackathon for a while. And I said, hey, let's go do some, not a hackathon, not software development necessarily, but let's test the various V4, V6 transition technologies that we've developed. So the two goals that I had come up with were to inform this discussion that we've had on the IETF list about whether the default SSID should be the NAT64 or should be 464XLAT or some other variation, and also to compare the various transition mechanisms. And so, well, let me come back to the team we did. So here's how we did it. We had this rodent domicile, rat's nest, that we created interconnecting a whole bunch of home gateways with VPP implementation of transition technologies. It took us a while to put it together. Here's the network diagram. You can see that the network diagram has handwritten notes on it because things change on the fly. That's why it's a hackathon. The CPE that we used was LEAD or LEDE or however that is properly pronounced. And VPP was used for all of the BRs and AFTRs for this. This is the team that was working on it. Actually, anybody in the room who's on this who helped work on this, would you stand up for a minute? So great work. I really appreciate all the work. At the end here, I note that Jen Linkova and Randy Bush specifically tested against IETF NAT64 implementations, and Jen's going to come up and give her slides in a minute. We tested these transition technologies and these applications, and everything worked except Steam was one that Jen noticed. The unable to reach certificate revocation list might have been a glitch in the matrix. That was a weird one for me because because I tried to reach the CRL that was offered by the Wi-Fi SSID, and it turned out that I couldn't get there on NAT64, but later I tested it again and I could get there, and I may have made a typo. We didn't get a chance to test MAP-T and MAP-E. It should work the same as lightweight 4/6. We just we couldn't prove it because we didn't have a chance to test it. VPNs, there was a special case because VPNs don't work if they're configured not to work, or if they're not configured to work. It kind of works both ways. And that kind of brings me to, well, let me go ahead and show this. This is essentially Jen's slide. She's going to come back and talk about her results. We tested dual stack light, and you can see lots of gaps here where we didn't actually have a tester in place or the facilities, somebody who could test that, or we somehow just missed the test case. The nice thing is almost everything we tested was green. Everything, most of what we tested actually worked. Spotify, interestingly, didn't work on Mac OS as an app, but it worked just fine with the web client. That's another one that I'd like to go back and test and do some packet captures. And apparently AirDisplay didn't work on Android, but worked on the Apple OSs. 464XLAT, similar results, not quite as many test cases tested. We weren't able to test most VPN clients because we just didn't have the right people at the table who happened to use those VPN clients. And sort of additional testing that we also did, but not rigorously and not well noted, was we tested Slack and remote desktop protocol on a couple of things. Next time, so these are some of my lessons learned. The first day setup was much harder than I expected. Took us a long time to get the configurations of both ends working together. Next time we do this, and I do think there should be a next time, I need to assign, or we need to assign test cases to individuals ahead of time, like fill out the matrix and put people's names on them and say, please come and do this. And that ensures coverage, but it's also makes sure that we have the apps pre-installed rather than trying to download and configure them and register on site, especially true with VPNs. We need to add these additional transition technologies, I think. And there's different work that isn't just what we do next time. Is the lead documentation for these transition technologies is sparse, if existent at all. I think I'm going to go ahead and say in at least a couple of cases, there's just no documentation. When you do search for how to configure it, you come up with email from Jordy to the lead development team. I think we may want to come up with some VPN best practices, how to configure your VPN so that you're not opening yourself up to the internet over V6. How to make sure that you're not, split tunnels are a really weird situation. George has been telling me about some of his unique cases. We've got some potential host requirements, some potential input into host requirements that Ule really is saying, hey, I think we've learned this. We really need to work on this some more. And we also need to test home electronics, stuff that I'm not going to bring to an IETF because, packing up a whole bunch of game consoles and stuff here, and dragging them on an airplane doesn't sound like a good idea, but I'm working on this. That's what I wanted to do real quick. Jen can talk about her results, and then we'll take questions for just a minute or two.
I actually sent you updated slide version because I would like to add Bill on the slides because he helped a lot on the hackathon. So,
I'm right next to you.
okay, so I said that I just sent you updated slide version, so if you can upload later, updated send because I missed Bill's name on the slide and I feel very bad about that. My apologies. So we had this discussion last time about how useful is IETF NAT6 for SSID. So I hope everyone who keeps their laptops open are currently on NAT6 for SSID. And if not, I would like to see tickets open explaining why what did not work. So we try to get more data about what is going to be broken if suddenly Vpv4 disappears. So it was a list of applications selected mostly based on the tickets which NOC received previously during previous IETFs, and plus some applications which we believe need to be tested, like applications which require for working group participations like MeetEcho, Jabber, and so on. So NOC helped. Thanks a lot for creating troubleshooting environment with mirroring all traffic to switch port and so on. So we were able to troubleshoot when something went wrong. So yeah, it was the metrics. So green means works fine. Gray means didn't make any sense to test because, for example, MeetEcho, I didn't test on iOS, Android. And orange means still needs to be tested because I had some issues with getting Windows 10 up. And red means it did not work. And surprisingly, it actually looks quite well. So Spotify application on macOS did not work because it looks like iOS application was fixed because of Apple requirements, but as there is no such requirements for desktop application, it still believes that if there is no Vpv4 address, there is no Vpv4 connectivity, and even on, and it's still trying to use Vpv4 address. And Air Display on Android behaves the same way. So application just complains, no, I do not have internet connectivity, please come back later. I found, yeah, it was another thing I tested, Telegram messengers, and everything works fine except for web-based key generation. So it's just sitting there doing nothing. But after, if you get keys generated, it works just fine. And I'm trying to find people who can fix it. And I filled bugs for a bug report for Air Display. So again, if you use Air Display on Android, you can complain to them. The most important thing actually was VPN, because I think it was the main concern, is that people could not get their work done if VPN applications do not work. And I see surprisingly good results. So OpenVPN works. Cisco people tested the corporate VPN and came back to me and it works just fine. So yeah, some corporate VPNs do have issues. There are vendors which do not support V6-only clients, but I've heard that some people might even consider changing those vendors to better ones. And there are some VPNs might not be just configured to work explicitly. And indeed, yeah, when you use split tunneling, it's tricky, right? Split tunneling might hurt even if you are on Vpv4-only network, because with all this DNS split horizon issue, you get DNS respond over VPN. It doesn't mean you can actually use that respond to send traffic not in the VPN tunnel. So it was actually quite good. Yeah, I say Telegram Messenger was also tested. It wasn't. So I learned a lot about various millions of instant messengers this week. I didn't even know so many of them exist. So we tested 2 more. They worked. I heard that some of them did not. I was told that Steam application does not work. And it's actually old version of my slide, two versions. So yeah, the most funny thing is all these fossils in your configurations. Check your SSH configs for host star family INET. Check your ETC hosts for explicitly specified v4 addresses, which means DNS64 doesn't help you much, and so on. So yeah, you might have some very interesting call configuration on your devices. Yeah, so there are indeed a lot of things to test. I'm pretty sure there are other VPN applications around. There are millions and millions of messengers. And again, it would be really nice to get more data about what people using at IETF network and what needs to work here to see if NAT64 is in the good shape to be usable as SSID here. So please use NAT64 this week and report if it does not work. Actually, if it works, it's also nice to know. So I think that's it.
Michael Abramson. Did you say you managed to get a Lady box to do the NAT64 plus DNS64 or not?
Which one?
A Lady box.
No, we were using VPP to do the.
Okay.
To do the
So I
translation.
have an OpenWRT based box, an Omnia Turris at home that I managed to in like half an hour to get that working as a NAT64 DNS64 box. I can probably try to get a normal out-of-the-box Lady and try to do instructions on how to do that. Would that be useful? So that anyone can set up a DNS64 plus the NAT64 box at home for testing.
I think having documentation that said how to do that would probably be useful. I think people would use that.
But,
Yeah.
So you did not find good documentation on this, so that would help.
I didn't look for how to do DNS64 and NAT64 on a lead box because we had the IETF SSID version using one vendor, and we had VPP providing another instance. So I didn't go that way.
Okay.
There was actually one more comment I needed to make on something else, which was in several cases we found that an application had problems, but once we upgraded it to a more recent version, the problems went away. Several cases.
Lorenzo Colletti, thanks for reporting this. There's another bug where it's mostly amusing, but the wireless controller in this network, if you don't do GHPv6 and you don't do EUI64, it's like, well, you're not on the network. So that's something that we're reporting to Cisco, because our devices can't get on the network at all, our new ones, because they don't do UI64 addresses anymore. And
I think we just had this conversation.
but maybe, no, newer. Yeah. So
Yep.
there's a lot of testing still to be done.
David Skenazy, Apple. I wanted to make a couple points on the VPN side. So, first off, thanks a lot for all this. This is really heartwarming, especially that things are getting fixed. On the VPN, configuration shouldn't matter. Since like a few years back, we went through and fixed all of the VPNs that are shipped with iOS and macOS, and you can try to configure them any way you want. You can't get them to not work. Because these VPNs, if they use UDP or TCP, they will go through a NAT64, just like they go through a NAT44. Like things that use ESP could be a different story. But if any kind of VPN that can go through a NAT44 can go through a NAT64. Otherwise, it's a bug in the VPN software. It's not a configuration problem.
I was under impression that at least at some point, OpenVPN could be configured to explicitly only use v4.
Yes, but so imagine this. If you configure it to say, this is a full tunnel VPN that disables all v6, which is what you want, because otherwise you're leaking all your traffic over v6. If your goal is to make a VPN that provides privacy, and your server infrastructure doesn't support v6, you want everything on v4, and you explicitly want to drop on v6, then what that would do is to the phone, it offers a v4 default route. It doesn't offer any v6, but underneath the VPN goes over TCP, UDP, over IPv6 through the NAT64. That case you're describing is that there's a bug in the OpenVPN code that they still haven't fixed.
At least last time I saw it, not this time. It was VPN was not even asking for Quad A, and it was, I think it was something configured on it, but it wasn't desktop. It wasn't phone.
But that's a bug in the client software. Like even if you configured it as I want only a v4 route and I'm connecting to vpn.example.com, that software should still be asking for a Quad A and have the underlying do Net64.
So one of the cases that I think this is different than what you described is I did hear of somebody describing that their IT department had them configured for split tunnel, and therefore their applications believed that they had V6 and could use V6, and then of course they're set to use the ISP's name server. In one case, they said they got it because they didn't have V6 locally. I mean, they didn't have V4 locally. They were getting a link 169.254 address, and this is probably more than we can solve here, and we ought to take it
no,
to a
it's
list.
something that we've already solved. That was my second point.
Okay.
Split tunnel and NAT64 is discussed in the Happy Eyeballs version 2 draft in 7 section dot something, and it's up to the client OS to solve the problem, because I agree that split tunnel makes this hard, but split tunnel and split DNS aren't going away. So this can be fixed in the host, and the RC documents how to do it.
Thank you, and that's probably exactly where we need to take it. But that doesn't mean it's been implemented by everybody yet. And you can still break a VPN if you try hard enough.
Absolutely, but in general, it's the software that needs to be fixed. The user configuring it wrong shouldn't be an option.
Hey, Kalitovich. So one comment on the testing. So we tested Skype for business, we tested Jabber, and we tested Outlook on Windows. It works. You can carry out your testing. My question, or I don't know, maybe it's a suggestion, is we had V6 certified. Can we have NAT64 certified for applications?
What is
That would boost a lot of confidence for a lot of people saying, yeah, this application has been NAT64 certified. Help speed up the V6 adoption bit.
So we do have RFCs describing it. I don't think the IETF runs a certification program. There might be somebody in the room who does run a certification program. But when we did the IPv6 Ready logo program, we had to write a spec describing the expected behavior, and then work with the V6 forum on developing essentially a compliance test suite that they could then use to test against. So there's work to be done there. I don't know any reason why it couldn't be done. And I don't see Tim Winters jumping up to say no. Oh, there he is. He is jumping up now that I've called him by name.
Okay, thank you.
Yeah, Tim Winters, UNHIOL. So for the V6 Ready logo stuff, obviously when there's interest in these types of things, that's when we go and do it. So if someone writes a really nice document that we can read and we can create a test program and there's interest around it, we would absolutely do that.
Jordi Palet. I was not sure to understand in your presentation, both of you, but especially for not just NAT64, but the rest of the transition mechanisms. I actually tried OpenVPN with TCP, not with UDP, but with TCP, and it worked in all the transition mechanisms that we tested. Okay, so that's clear. And also responding to what Michael said, I have already implemented in a CP like this $10 NAT64 and DNS64 on OpenWRT. So that's feasible as well, and it works. Yeah. Well, not instructions, but I will make it. I am going to document everything what is missing in LEDE for that.
Okay, I need to cap the mic after Lorenzo.
Daniel Shaw, Afrinic. Quick question in regards to the testing of all the different instant messaging, Telegram, Slack, WhatsApp, Skype, etc. Did you differentiate at all between text, voice, video?
Yes. So when it's green, it means we tried video if Messenger supports it. Yeah, because text works all the time, but yeah, there are cases when video is not possible. Yeah.
Cool. Thanks.
I want to respond to that too, because I don't know that on the other transition technologies, I think that we did test all functions in all of them, but I don't know that we did. Jordy's saying, yes, we did test all functionality. Good.
Yeah. And I would say when more we try to make sure that we have a video between a client on NAT64 and V4 only client, because if you have two client on 2v6 networks, it's probably, should work, obviously.
Lorenzo Coliti, to reply to your comment, Jordi, I think it's not as easy as you say. So I've gotten NAT64 DNS64 to work on OpenWRT, but it's dog slow, really, really, really slow, because Taiga punts the packets to user space, and it's not really an acceptable solution for a mass market device, which is going to have a CPU that's as small as it can be.
Well, that makes it a feature, right?
But Joule is not upstream, right? So you have to like integrate it into your kernel. Right, but it's not in an upstream kernel, so you still have to do integration work. So it's you know it's not trivial. For testing, yeah, it's fine, but you know.
Okay, thank you.
I'm staying, I assume.
I'm sorry?
I assume I'm staying.
You're next.
Yeah.
I believe so, yeah.
All right. So conditional arrays and enterprise multi-homing. So I don't know. I just quickly remind you what's all about, right? So we have a problem of enterprise networks which want to use PA address space and be multi-homed at the same time and do not run BGP. Right? So how can we do this, especially if we look at the situation when some uplinks might go down, come back up again, and so on. So there is a draft adopted by Routing Working Group, which describes a solution for quite a general use case. And the problem is, the problem is that the solution proposed there, which tries to cover almost every possible scenario, requires host to use Rule 5.5 of default address selection algorithm to select a next hop router and then select the source address. Because again, the problem is how can we tell host that this prefix should not be used right now, because uplink, for example, is either down or it's your backup uplink and you do not want host to use the address space from that ISP. So this draft documents tactical solution which could be implemented on any network with reasonably modern clients. I mean, clients which support the current version of default address selection, even without supporting the Rule 5.5, which is optional as per default address selection algorithm. So the whole idea is if a host is allowed to use the prefix, because uplink is up and operational, and you allow host to use it because it's your primary or you are load balancing between uplinks, then the host just receives PIO with non-zero default lifetime and can use it. If network needs to signal back to host that this prefix should not be used because the uplink is down or it's your backup uplink and you do not want to send any traffic there yet, then prefix is deprecated by sending array with preferred lifetime 0 for this ISP. So here is a link for my slides from last IETF, which covers the solution in more details. And now I just tell you what's happened since Prague. So the draft was adopted, and after this very productive discussion we had in Prague, I think I addressed comments received. So now I explicitly clarify that when network state changes, it's not just one array being sent to signal situation to the host, but all subsequent arrays, I have the same parameters. So for example, if one uplink is down, that all periodic unsolicited or solicited arrays received by a host would have preferred lifetime 0 set for this prefix. So yeah, at any point of time, basically the array sent by a router should be consistent with the desired network topology. So in the previous version of the draft, I didn't make it clear what should be done if all uplinks are down. Shall we deprecate all prefixes or do something else? And I think that's based on the discussion we had. Now the draft clearly states that if all uplinks are down, that all prefixes are deprecated. So I added the reference to requirement from CPE, which says similar things. And I also clarified the limitations for the proposed solution, because this could be used in a scenario when the network has 2 or more uplinks to internet. It probably would not work very well with tricky walled garden scenarios and so on, but I believe that this use case is quite common. So solving it would be really nice step forward, helping enterprise networks to deploy IPv6. So why I'm here? Because I sent link to updated version to the list. First of all, I would really like to hear from people who find it useful and would like to see it implemented, and would be interested in probably deploying it. So I would like to see if it's just a problem I'm trying to solve, or there are other people who would use it. If you'd like to use it, please talk to me during this week or after, whenever you want. And any additional feedback, how shall we proceed? Because I'm happy to address any feedback received, but so far my to-do list is empty.
Eric Nordmark. So this seems like a useful thing. I was wondering about hysteresis when there's like link flaps, and whether you immediately would send it as opposed to waiting for 5 seconds to see if the link comes up. And in the past, there's been some host implementations that would immediately go kill TCP connection. Oh, that's when it becomes invalid, I think. But so I have to look at whether hysteresis is useful when it goes up and down, and that might be something to consider. I don't know if there's an easy way to test this stuff, but
yeah, I think it might be potentially useful to have some delay before you propagate the change of the network, right? Because currently what I'm testing in the lab has delay because I'm using some automation, because vendors do not do it. Like I could not apply a policy on a router saying if this uplink is down, like you do in the VRP, right? Please update the array configuration. So I have to do some scripting which introduce the delay. But maybe you're right. Maybe it should be some kind of dampening and not propagating change immediately.
If it went down and then comes up 5 seconds later, well, do you immediately advertise it again, right? As opposed to saying, oh, let's wait and see if it's really stable because it went down and came back up quickly. I don't know. And then if it's your only prefix, well, the rules might be different than if you have 2 or 3. But
yeah, you're right.
Renzo Colletti, have you tested? I guess it would be useful to test on various implementations. I think I'm pretty sure that on Android, if you deprecate all its addresses, it'll say, "I don't like this. I'll get the hell out of here." You could, I guess you could certainly say that we should not do that, and we could. I think the challenge was that we saw that on certain networks, when addresses were deprecated, it was because they'd actually timed out and we actually had no route. But we could consider changing that. But if you had an implementation report, if you tested on various implementations and you told us what was wrong, if anything, then we could fix that.
I think it's more kind of related to network design, because, for example, if we're talking about, small office with few people, right? Few users sitting there. Maybe when all your uplinks are down, it's a full outage, right? If you're talking about something more complex, you might want to use ULAs there to keep intra-site connectivity up, because you want to probably connect to your printers or your workstation or something. I'm not sure, because ULAs have place here for keeping your intra-site connectivity in case of internet outage.
No, just have a report on how testing affects hosts.
Okay.
Because then if you find bugs, then we can fix them.
Okay, cool.
Michael Abramson. So I think the HomeNet proof of concept code already does a lot of this. You could probably use that for testing as well instead of the orchestration you were talking about. I think I mentioned this last time as well, that this is a lot like when you're sitting on the user side of this, it looks a lot like sitting at HomeNet or this solution. Some of the machinery in the middle in the network might be different, but from a device perspective, it's probably very similar.
Because I was testing in my particular scenario when I needed to have particular setup work.
Okay. So thank you, Jordy.
Okay, so I presented this document in the previous IETF. It's still version 00, but actually should be 01. I make a mistake with the naming, and then the data tracker didn't wanted me to upgrade the number. Just going very quickly, because I don't want to repeat everything I said the last time. The situation here is that happy eyeballs is good for the user, but actually is hiding problems in the network to the operators. Yes, I agree, the operators should be monitoring their network, but actually they don't do at the same level as with IPv4. So what I am proposing is a kind of extension to happy eyeballs in order to an automatic reporting of the issues. For simplicity, and I am not saying if we go on with this work is the only way to do that, but for simplicity at the moment, I think that the best way, because it's something that usually is already in operators' networks, is to use 6LoC only with UDP, only with the default port, which is 514, and only using IPv6 links to report the problem, because it's supposed that the link to the operator should be working. If not, the operator has a bigger problem towards those users. I am also using an existing protocol to report or to actually find the 6LoC server in the network. So it's again nothing new. It's something that already exists there. And I am using basically the same system as for finding the NAT64. Okay, so it's nothing new. Just I am using a specific address that it should not be used. And anyway, because I am using IPv6 only, it will not conflict with any other existing protocol if somebody still has 624, which is the address I am using configured there, because I am not using the IPv4 address, but the IPv4 address as part of an IPv6 address, which is unique to every operator network. Okay, so this is some of the comments that I got from the previous presentation. That's not going to be an issue, even if somebody has still 624 working there. So the idea is that when happy eyeballs detects a failure, it should use the 6LoC server to report things that need still to be defined. It's something that we need to work with the OS vendors probably, like timeout parameters, failed destination address, and source prefix. And one of the major concerns that I heard in the previous meeting was about privacy considerations. Okay, I have been working with a new co-author that I have for the document. I think it's somewhere here in the room, Carlos. The idea is, first, we believe that this information is already being collected by vendors and operators. And in general, current regulations allow collecting the data. What they don't allow is to disclose it, okay? We have a similar discussion with Carrier Graynat in the list, and also with Europol and so on, and all this data is being done. The difference is you are not allowed to show that data outside of the technical management of the network, right? So it should not be a problem, but anyway, we have been considering a soft version of this problem or this work, which is we don't really need to report the source address or the source prefix, because in most of the cases, it will be enough if the operator knows that some destination from within his network is not reachable with IPv6. That will solve probably, I don't know, 70, 80% of the problems, which is a lot, okay? So this is a very simple diagram. Let's suppose we have a few customers in different kind of networks connected to an ISP, and the problem can be in different places. If we report both the source and the destination, of course, we know exactly where the problem is. If it's inside the customer network, if it's in the access network of the ISP, if it is within the core network or transit of the ISP, or if it is in the transit providers of at the destination network. If we don't report the source address, we are not able to understand if the problem is inside the customer network or maybe in part of the access network. But we still know that we have a problem either in the transit or upstreams or to a destination network. So it's a decision that we need to take. If we want to get rid absolutely of this source address privacy consideration, we can go through this way. So I think basically that's answering the main concern that I got in the previous meeting. I think there were other questions like incentive to deploy, implement this. Well, I think the incentive is the same as Happy Evolves, is improving the IPv6 deployment quality. That's obvious. There was another question about DOS vulnerability. If I understand that, because the syslog is the same as you have today with any other syslog, so there should be no difference. You are already, if you have a syslog, you are already protecting that server somehow, maybe not allowing reporting from outside your network or whatever, or rate limit or whatever. There are more things to work, yes, of course, but I think having this document as a working group item will help to get comments, because basically, as the case for the previous presentation from Jen, we didn't have any comments or any inputs in the mailing list, so hopefully it's going to improve. Oops. 1, 2. Open questions. It's possible to do this reporting with both IPv4 and IPv6, but I believe that if we are looking into the future into IPv6 only, it makes much simple to report using IPv6. If the IPv6 access to the customer is broken, then, as I just mentioned, you have a much bigger problem, right? So you probably need to detect that somehow in a different way. In that case, basically, you will not get the reporting. And then, well, I have a question, but I guess it's a procedural question about if it's possible to ask IANA to reserve a specific address used before, but that will not change the problem because we could use any other IPv4 address. Main changes from the previous version, as said, numbering is incorrect, but whatever, never mind. There is a new co-author to the document, which is Carlos Martinez from LACNIC. And basically what we did in the document is extending the privacy considerations, which I think was the main concern that remained unresolved from the previous meeting. And with that, questions?
Michael Abramson. So I don't remember if we discussed this at LATME. What was the rationale for choosing .1 in the prefix? The exact same address as the 64 relay. What was the rationale for choosing that address and not another address in that /24? What was the rationale for choosing .1?
Well, actually, you can choose the /24.
Yeah, yes, but you're specifically saying .1. .1 is used as a 64 relay. HE.net is still running a 64 relay on that address from one vantage point.
But never mind, because I am not using actually the IPv4 address. I am using the IPv4 address as a suffix to an IPv6 address.
Okay, so this whole thing about if you were doing this in v4, then it would be a different...
Yeah, but I am not considering right now doing that in v4. It can be another address. I mean, that's something that we can change in the document. It's just a suggestion right now to make it easy. Okay. We can define any other address.
I would suggest picking out a v4 address. If necessary, you can pay the $10 and buy it. On the question of whether to report from using v6 or v4, it doesn't seem to make sense to report this over v6. Like if Happy Eyeballs fell back to v4, it means that v6 is broken. And we've seen a lot of the cases where we see that v6 is broken, it's actually the last mile, not something in the core. So at least in our experience, it seems like you're better off doing something else, either reporting out always on v4 or using Happy Eyeballs to do your report, right? Because if there's an outage and you see an error, then the user can report that error. What you're worried about is silent failures where the system falls back. So then use the same fallback behavior and you'll be guaranteed that it's going to work. If you just use V6, it may not work.
If that's the case, well, we will need to change the document to do the reporting either only in before or try V6, and if it fails, report with before.
Just use the same algorithm used before. By definition, it shares fate, right?
But in my experience, what I have with customers deploying IPv6 is most of the time, the failure is not in the access network. That's my experience. That's a different.
We see loads of bugs where the CP gets a new prefix and stops working. It's so.
We will. It will be interesting to have that information from vendors, but really my experience and people which we talked, for example, about this in the last RIDE meeting is most of the failures are in the transit or in the destination, not in the access network.
So Fred Baker speaking as an individual. First comment, I think you just argued yourself into a happy eyeballs approach. Reason being, we've got differences of experience and producing opposite results. So I think you wind up having to try them both. Okay, but the reason I stood up here, Khalid.
I don't hear very well you. I am not sure if the audio in the room or whatever.
I think you wind up needing to use the happy eyeballs approach, which is what Lorenzo was suggesting.
So it seems that what I hear right now is that it will be better to report either using V6 or V4.
Right.
Yeah.
Correct. Okay, but Khalid, I've got a question for you. Okay, whatever.
Well, the point, if we want to report before, is that the way to discover the syslog need to be modified, but
Okay.
we will find a way. Sure.
You're right. There's no ACK. So okay. So you can't use happy eyeballs. You just send two UDP messages, and bite the bullet on the fact that they can be correlated. Yeah. Okay. So Khalid, in your talk, you said that dual stack worked against you and that the happy eyeballs approach was a problem, which is to say that Jordy's talking about what you were talking about. Do you have additional comments you want to bring in from an operational perspective? Okay.
You can use that.
Thank you. So, Fred, our view is also that the problems lie either in the transit or the destination. That's what we found in all the diagnosis we've done for all the cases where we found issues. I can cite specific ones, but yeah, that's where we found it.
Okay. So I just wanted to make the correlation there.
Thank you.
David Skenazy, Apple. Silly question. If the problems lie in the transit and the destination and not on your network, why do you need any reporting? Because you can't fix those.
If you don't get the reporting, you don't know it happens. I can tell you some examples, and probably similar situation as Cisco mentioned. I have got one national bank from a country telling me, hey, we have deployed IPv6. And then I was testing it, and it was not working. And partially the problem was the transit, the international transit. And the interesting history out of that was that when we checked his transit provider, they discovered that the IPv6 link was presenting failures since 1 year ago. And I agree, it's something that they should monitor. But this is a way to warn them, hey, something is happening. And even if this is not going to tell you where is the problem, at least you are aware there is a problem, so you can tell to your transit, because you keep the destination address, hey, you have a problem, or the transit, or already the last mile, okay, the web server or whatever is it.
Thanks, that makes sense.
Thank you.
Other question. So on the slides, you mentioned -01. I couldn't find that on
No.
data
What I
tracker.
mentioned is, I make a mistake when I submitted version 00. When I tried to send version 01, because I changed the title to correct the mistake, the data tracker didn't want it to accept 01 for a non-existing previous 00. So I make a new 00. So this is the second version, but it's still 00. Okay.
Okay, thanks. So I couldn't find it, so I haven't read that.
If you look at the document in the history, you will see 200 versions with a different title.
Okay, because the one that I did find and read, the security considerations section said we don't have any security considerations, and that's terrifying. This is a huge privacy breach that can be mitigated and must be mitigated. Right now, syslog over UDP, unencrypted? Really? Like, what century is it? Like, this is leaking what the iPhone user is connecting to. That's like one of the holy grails of privacy right there. Even if like it's encrypted, I'm going to need a lot more than we have a soft approach and we don't log your client IP. Even if it says must in the RFC, that's maybe not even good enough. So I think we need to really sit down and talk a lot more about privacy if you want the client OS to adopt it. Because going back to your point about incentive, these aren't the same incentives as deploying Happy Eyeballs. We didn't deploy Happy Eyeballs to make IPv6 better. We deployed Happy Eyeballs because we had deployed IPv6 and people were turning it off. In this case, that's done. The incentive for this, there's no incentive for us as a client device. The customers are already happy. Their eyeballs are happy because of Happy Eyeballs. This is to make your network better, which I want to help with, but the incentives aren't there. So we're really going to have to work on making the incentives and B, convincing us to build a way that's privacy preserving. So maybe using something like differential privacy or something.
I think, I'm not sure right now, I don't have the text here, but I think what they said is no new security issues. So of course, if there are security issues from previous protocols, I have the same. I agree with that. It could be improved. Let's work on that.
No, this is a new security issue. Now I'm reporting to you the websites that I'm connecting to, like literally in writing on syslog protocol, and I didn't do that before.
Let's work on that.
Let me stick in the middle here. I think actually we're not identifying a Happy Eyeballs problem. We're identifying a syslog problem. Syslog should be using DTLS.
That's a step in the right direction when the attack vector is someone sitting on your open Wi-Fi at home. But that doesn't solve the problem where his box that has the syslog results gets compromised, and then someone can see all the websites I've been connecting to.
Okay.
I mean, yeah, where to start, right? I think, I really think if you want this to be implemented, it basically is a security problem, and this is actually creating lots of security problems. I'm not even like qualified to comment on your assertion that it's not a privacy breach unless you disclose the information. It doesn't seem credible to me, but like I'm not going to talk about that. I think you'd be much better off doing some sort of flow analysis and getting this done on a statistical basis, to be honest. If you're looking at TCP, just look at SYNs and SYNACs, divert them off to a mirrored port and like see if they come back, right? Because the traffic is going to be symmetric at the customer endpoint. Just do that. Yeah, you can standardize this. We're never going to implement it because it's a huge privacy hole, right? So, I don't want to get in the way of useless work, right? If it's harmful, I'll get in the way. But if it's useless, then it doesn't matter, because as long as we don't implement it, there's no problem, right? But I think if you want it to be relevant, then I think you have to think about, you really have to deal with the privacy issues, like you did, and that's a big bull to take by the horns.
Well, at the end, I think that if we believe this is useful, and I think for several comments is useful, we want to do this. Maybe the way that is being proposed right now is not the best one, but what I am saying is please provide inputs about that, about how to do that, how to improve, and we will move into that direction.
Yeah, there's a difference between improving something that's almost there and improving something that's in the wrong direction. But yeah, maybe it can be improved.
Janinkova, 2 comments. Actually, yeah, it's quite interesting to see 2 different worlds, because as someone who operates reasonably sized enterprise network, almost every failure I see is the last mile. So it's almost never somewhere in the destination. And my last mile. Otherwise, I wouldn't know. So, but back to security. I can give you one security scenario. You requested what, new V4 address, new V4 block for this, right? And if my ISP has no idea about this technology and I get an endpoint which implements this, it will send UDP traffic to some destination which someone else might advertise to my ISP. And what, my traffic will go there, and some people somewhere on the internet will get some interesting information about all sites I'm trying to reach if my IPv6 is broken. I kind of do not like it.
Chris Morrow, Google. Not really for Google's purposes, but I'm trying to understand why I would care about this. So, David said he had sort of the same question. He said, oh, okay, maybe at the end he was okay with it, except for the security problems. If the problem is on my local network and I'm an enterprise provider, okay, fine. I'd like to know that I have problems with my network, but maybe I could monitor that in some fashion, and that would be cool. If I'm not doing that today, I'm probably not going to do this. If it's the problem is on the remote network, I can't really tell them there's a problem so much. Like, they're not going to listen to me. I can call Telecom Italia and say, something is broken, and they'll say, we don't know who you are, go away. Right? Which they do. That's fine. So other than sort of research papers saying, oh, we see X% of things are broken, I don't really understand what the point is. And then add the syslogging everybody's web requests. That's a bit horrible. So I guess it's a neat hack. I appreciate that, but I don't really understand why I would ever do it. So sell it, please.
Thank you. So, done?
So I think where we stand, we're not ready to think about adoption at this point. Several issues have been raised in the last few minutes, and if you could address those, then let's
Thank you.
see where that goes. Now, don't go too far, Jordy.
Come back.
Jordy, come back. So we've got another half hour. So I'm going to move one of your drafts forward from next week.
Do we care?
Whatever. I don't know.
So what am I doing?
Just take
And by the way, I haven't got your 464X slides yet.
Oh, I attached it.
You told me that you created them, but you haven't sent them.
Okay,
to me.
I
So
will send it right now.
In any event, so talk about this.
Yeah.
This will probably take half an hour.
Okay. Okay. I started this document because when we talk among us, sometimes we are saying IPv6 only. And in fact, even talking with some of the co-chairs some of the times about some specific documents or work or situations in networks, we are not thinking the same. So I have a position about what is IPv6 only, and some other people has another one. So, and I think it was Lee in the previous meeting said, maybe we really need to have a definition or a concrete definition of what is IPv6 only to get in sync. So, well, the first version of the document, some people was not understanding what I was telling when talking about forwarding IP in layer 2, layer 3, or whatever. So I changed it completely in this version of the document. And basically what I am saying is, let's define what is the specific scope or what the specific network part when we say that we have or not native support for IPv4 or IPv6. Okay, so that's the basic idea, to really say, instead of IPv6 only where, and in the sense of native support of one or the other protocol. So this is an example of a network. So we have a network which has cellular, residential, and corporate customers. And in this case, I am using an example for 464X-LAT, which many people will say, hey, that means that it's IPv6 only, because basically you have only IPv4 in the transit, okay? In the plat, in the NAT64, and so on. I don't know, will you agree that this is an IPv6 only network? Some people told me, yes, this is IPv6 only, but because inside of your network, basically, you can have everything which IPv6 only, and that's true. And you can have, of course, dual stack at the LANs of the customers, but you are not actually transporting IPv4 natively, okay? So if we agree this is IPv6 only, then now we want to look at every specific part of the network. So for example, in the cellular network, it's true that we have IPv6 only in the access, in the WAN, but still the cellular phone can have dual stack. Question?
Do you want to take them at the end or during the flow?
I don't know. How do you prefer? I am okay. I am okay, yes.
So you have included in this diagram technology that has no arbitrary layer 2 packet forwarding capability. The cellular component is a constrained network. So I, as a customer, can't bring a device that can make it attempt to do ARP, because ARP does not reside inside that layer 2 fabric. But the corporate network could say, oh, we are V6 only, but if they have not deliberately constrained their switching fabric to terminate the forwarding of certain kinds of layer 2 packets, that's only an administrative statement. It is not literally true. And I feel there is this quality lurking underneath what you're saying. If you want the corporate net to be an IPv6 only LAN, you really have to say it's looking for layer 2 packet types that would be required and forbidding them.
Well, in general, what I try to do is not to say if the devices or the network has the capability of being dual stack or not. What I am saying is if actually from the perspective of the operator, he is or not transporting natively IPv4 or IPv6. I think that's the small difference. So maybe we need to fix that in the document, saying, explaining what you just said to differentiate both situations. Yeah.
Yeah, this is Alexandru Petrescu. I see you picture there a cellular network, and I still have to read the draft. And I hear you call it IPv6 only. I believe there are at least two kinds of cellular network that support IPv6. And actually, I think none of them is IPv6 only. And this is why maybe I have to give you some comments separately.
So you mean there are no IPv6 only cellular networks?
Yes.
I agree with you, because the cellular device can run both V4 and V6, but the one is IPv6 only. That's precisely the reason for this document. You see the confusion?
I don't understand. Say it again.
Yeah. Many people is saying, I have an IPv6 only cellular network.
Yes.
They are correct?
No.
Not.
No, they are not.
That's what I am trying to fix.
Yeah, in terminology.
The cellular network as such is not an IPv6 only cellular network. The one link, the access, is IPv6 only, but at the end device, you can run dual stack.
Yes, on the end device, you can run dual stack, and in the core network also, those networks that provide IPv6 only to the smartphone, also in the core network, are both IPv4 and IPv6. They carry IPv6 inside GTPv4.
The core network maybe not, well, depending on what you call the core network.
Yeah, well,
but maybe the core network is only IPv6, and you have IPv6 only at the NAT64. That works.
No.
Yeah.
No. There is no core network IPv6 only in cellular networks. Okay.
Okay. In any case, precisely what I am trying to say is when we say whatever only, we need to put the scope. We need to say.
I agree with that. Yes.
Exactly. So
Yes.
that's the reason for this.
Yeah, and I will send comments separately.
Yeah, so it's worth noting that the same network can at the same time support maybe v4, v6, and v6 only links. So yeah, it's not a property of the network, but it is a property to the point-to-point channel you establish over that network. There is most certainly an IPv6 only PDP context that is only v6, right? So, sorry? Or v6 only SSID, yeah. So the logical link layer, there definitely is v6 only link.
Joel Yeagley, it seems like there's a semantic distinction that's being teased out here where client isolation is such that you either do or do not have v4 and you do or do not have v6, right? If you don't have v4 on the client or in the client's immediate upstream connectivity cone, it's irrelevant whether the rest of the network supports v4 or not. Right? Because client can't use it. Even if the client does it internally, it's not present. So, like, to the extent that, that isolation is enforced, where it's enforced actually describes what kind of a network you have, right? Because by and large, we do not have layer 2 broadcast domains, which have multiple hosts associated with them, right? So you don't have the case where the clients could have v4 and the rest of the network does not.
Hi, Alan Durand. I kind of agree with the previous comment. What matters is what the client can do, right? What's in the network is X25, doesn't matter. But my point is, if you call IPv6 only a network when you can have IPv4, how do you call a network where you cannot have IPv4?
Okay, what I am saying is if the network is transporting IPv4 natively or not. I am not saying cannot have IPv4 on top of an IPv6 only link. It's the same as when today we have an IPv4 only network, which most of the ISPs have, unfortunately. Users can still have tunnel brokers to have IPv6 service, but the ISP network is dual stack? Not. The IPv6 network is, in this case, IPv4 only. You see the point?
Honestly, no.
Okay.
This is again Alex Petrescu. I wanted to say something that I agree with. Earlier it was said that in cellular networks, the PDP type is IPv6 only, and I agree to it. Okay, so that's also a good term to say. Yes, the PDP is IPv6 only. That's all.
But also, that's in the case of a cellular network. It's just one example. If you look at fixed networks or non-cellular networks, you will see that there is not something like a PDP type IPv6 or type IPv6 before.
Yes.
So that's the point.
Yeah. PPP, he said PPP. Yeah.
Well, not every network uses PPP. Yeah.
Also, with respect to the definition, I think there is no operating system that does not have an IPv4 stack into it.
Again, I am not talking about operating systems. I am not talking about the capability to support both protocols. I am talking about the actual native transport. What is the actual native transport? IPv6 or IPv4 or real dual stack?
I don't know.
That's what I am talking
about. I don't know
about.
what you mean by native. Do you have an alien or a native or just native?
Native.
Native. I don't know what you mean.
Forwarding only IPv4 or forwarding only IPv6 natively.
Okay.
Okay.
Marco Elgewaning, right, NCC, again wearing the hat of one of the people who's trying to sell this technology outside of the room. You're not really helping here. This is already a very complex case. For the last 10 years, I've been explaining to people that in the case of an IPv6 only network, yes, there will be residual connectivity to IPv4 services. You're not losing anything in your transitioning. You're not helping me here. from an end user perspective, and even as sort of Joel mentioned, and I think Alain was also going there, from an implementer's perspective, you have a V6 stack, it might work, it might not. You have a V4 stack, it might not work, it might not. Certain cases, something doesn't work. We have a simple word for that. It's called broken. We don't need the draft to overcomplicate this. Thank you.
I don't think you don't got the point here, because what I am saying is that there are going to be, and there are already, some service providers that either in cellular or non-cellular networks will deliver, and they are delivering IPv6 only access, for example, if we talk about the one link. So in that case, we want to be very specific when we say IPv6 only, if it's the full network or only part of it.
That provider either sells me internet connectivity or she sells me something horribly broken. That's where I'm coming from. But
yeah.
David Skenazy, Apple. So conversations that I have at the IETF, it's true that for some people, the IETF NAT64 SSID that everyone in the room should be on is V6 only. For some people, it's not V6 only. And it's true that there's some confusion there, but we generally clear it up pretty quickly. I then read your draft, and now I am 10 times more confused. Hearing the questions and your answers, I am still extremely confused. So I don't know what problem you're trying to solve, and I think you're making it worse. At the end of the day, whoever you're talking to, you're going to have to explain the terms anyway. And having a document that says, no, really, don't call it SSL, we rename it to TLS. People, stop calling it SSL. Doesn't help. Like we don't even have a problem to solve here, and I'm just completely confused now.
Well, I don't really agree. I really believe, and after this conversation, I think it's more obvious that not everybody has the same understanding of what is IPv6 only or not.
Agreed. And fair point. And not everyone has the same understanding of your draft.
Okay, let's fix it. I mean, the point is, if we don't have a concise terminology, we are not going to get out of the confusion. That's clear.
John Rinkova, on one hand, I understand what you're trying to do because it's really nice to...
I don't hear you.
What's going on? So, John Rinkova, so on one hand, I do understand what you're trying to do, and I appreciate that. It's really nice to have a common terminology, but I think when you're trying to define something which is in this area, you might, as been said, you might create more confusion by trying to define things. Because, for example, I look at your definition of IPv6 only local area networks. You say not natively transporting IPv4. If I have a router and a host and a switch in the middle, and my host has V6 address, and switch obviously will switch Ethernet packets with V4 inside. Is it IPv6 only if a router doesn't have V4 address? Or if router has V4 address and we do not provide DHCP V4? Or how would it look like?
If you are talking about a local area network,
Yes.
In a local area network, if it's IPv6 only, it means there is no native IPv4 traffic. That's
What
the
do you mean?
point.
I can send IPv4 traffic, right? I can configure IPv4
If you are sending IPv4 traffic, then it's not native IPv6 only. That's obvious.
When I put one single client with static IPv4 address on something which you consider being IPv6 only network, like IETF NAT64, IETF-V6 only SSID, it will suddenly make this network not IPv6 only, but dual stack, right? I don't think so, right? But it looks like it because there is a V4 traffic on this network. I might start sending some V4 traffic on this IPv6 only SSID. Because
Okay,
client
so-
might create some IPv4 traffic.
So maybe the actual definition in the document of an IPv6 only LAN need to be fixed considering that. But for a one link, I think it's clear. In a one link, you are not going to send IPv4 traffic if it's only admitting IPv6, right?
So I think part of the problem is you kind of mixing technical administrative definitions, right? There are administrative actions which might make your network V6 only, and there are technical things. If, for example, on your LAN you deploy filters on layer 2, which prevents it to happening. Yes, it's one thing. But if I'm just design my network as being V6 only, which means I'm not supposed to provide V4 service, it's a different thing. So I actually start thinking that probably we should leave it like that and let people, when they talking about particular network, to define what they mean by that, case by case, because it might be different case every time.
Lee Howard, a couple of comments. I stood up to get in line to respond to Marco to point out that not all networks are internet networks, and that terminology like this will be used on IP networks that aren't necessarily connected to the IPv4 internet. That still makes it an IP network and may even still be an internet network, even if it can't reach IPv4. I don't believe that IPv4 will exist forever on the internet. Maybe effectively forever in some pockets, like we have obscure protocols still running in data centers now. But I don't believe that what we think of as being the internet, the largest subset of internet of interconnectable devices, will always include IPv4 addressing everywhere. But I think what I'm hearing from the conversation, and this may be more of a putting a chair hat back on as I'm looking at my co-chairs, is I'm not sure that we're hearing from the comments here that there is a problem that we need to solve. If we hear that, if we agree there's a problem that we need to solve, then I challenge us to go figure out, all right, maybe we still don't have the right, maybe we're nowhere close, maybe we're close and haven't quite gotten there yet, I don't know. But if we don't agree there's a problem that we need to solve because there's communication, then there's no point in advancing the document. I will point out that I'm not connected on my laptop over there to the NAT64 SSID. I'm connected to the IPv6 only SSID, and the NAT64 one isn't V6 only, but that's, we've got a terminology collision right there.
So speaking as chair, my feeling at the moment is that we don't have a universal consensus supporting this draft. That a fair statement? No. Okay.
Okay.
If I was to go ahead to your customer prefix draft, do you think you could do that in 13 minutes, or should we leave that until
I
Thursday?
think we need to leave to the next
Okay,
session.
Fine.
Yeah.
Thursday it is. And I need your 464 excellent. Okay, cool. So we're adjourned for today. We'll come back Thursday morning. Yes. Let me. Yeah, well, I'm sure you did the right thing.
Don't feel bad. I woke up at 4. Yeah. After going to bed at 11, so I had 5 hours sleep. And tried to work out. I just didn't have enough mental keeping it together to do it. 15 minutes and I gave up. Well, see you guys in a bit.
Yep.
See you in OPSEC.
Okay.